Okay, go ahead.
Can you see my screen okay?
Yeah, I can see your screen.
Okay. Hello, my name is Jay, and I will be introducing the GFS dashboard. For assignments 2 and 3, I implemented GFS in Python. As I worked on implementing the system from scratch, I made a lot of mistakes. After fixing a bug here, another would pop up there, and early on, I found that debugging a distributed system was challenging. In particular, I found it challenging because it was hard to keep track of the plethora of messages and the types of messages that were exchanged, as well as tracing their origin and destination. And when failures occurred, it was often time-consuming to trace the error back to its origin. In addition to debugging struggles, I found it extremely cumbersome to verify the working order of the system. For example, to check that records are correctly written to a chunk server requires first parsing through the master server's metadata to identify the location and the handle, then rummaging through the chunk server's storage and parsing the appended records, and repeating this process to verify each replication. Finally, when the system grows in size to support multiple clients and more than 3 replicas, understanding the state of the network can be next to impossible. If some component were to fail, having a concise and an effective way to identify failures yields early detection of inconsistencies. So the GFS dashboard is my solution to this problem. The purpose of this web server is to monitor the network behavior and the state as the client interacts with the distributed file system, and transforms the network log into informative and concise representations, and allow clients to examine and interact with the system without the need for code. Moving on to the demo. On the top left is a chart of the network message history of the system. Each horizontal line represents a node. So we have the client at the top, then the master node, and the replica nodes at the bottom. Time flows from left to right, and the colored lines denote that a message has been transmitted from one node to another. For example, the blue diagonal line here that connects the client node to the master node signifies that the client sends a message to the master. And the type of the message that was sent is labeled at the bottom here. In this case, the client requested to get the view of the current working directory from the master. And the purple line here is the response by the master node with the file system metadata as the payload. The client uses this information to populate the Explorer panel that you can see on the right. The panel on the top right here is a file explorer for the GFS. Rows colored blue are directories. And below, and in rows with the black bold font colors are files. And below the file name, you can see the chunks that make up the file. And each row in red represents a chunk located on a specific replica. The input at the bottom here prints the current working directory. So if I click on the test directory and move into that directory, the current working directory updates to show that. And to create files and directories, I use this to name the file, and if I submit that, then you can see that the test file has been created in the test directory, which I am currently on. And performing this action fired events emitted from the master to the replicas, as you can see here. From the chart, we can see that the client initiates the create file event, which is passed to the master, and the master broadcasts it to the 3 online replicas that each emit back an acknowledgement to the master. And when all participating nodes acknowledge, the client requests the updated view from the master. And with the response, it renders the Explorer with the updated information. Moving on to the client terminal, here at the bottom left, the main text area logs the network message payload. So all network activity is appended to this log in full, providing a way to inspect each message plotted in the network chart above. The 3 input fields at the bottom provide an alternative way to send commands and request information from the file system. It can forcefully send messages from the client to any node in the network, and it will be useful in identifying potential vulnerabilities in the GFS API that may grant a malicious actor from triggering a failure or accessing information outside its permission. And lastly, to the bottom right here is the operation log, which displays the state of the master node's backup system, which keeps track of the critical operations so that it can recover in the event of a master failure. My implementation flushes the operation log when it reaches a size of just 1 and creates a checkpoint when it's flushed. And clicking the auto re-replicate button here triggers re-replication strategy of the master node, which in my implementation is just to re-replicate a chunk up to 3 times if the number of replication is below 3. So to test that out, I will delete some replication for the file hello. And currently it's just 1 replica that has the information. And running re-replicate will perform the strategy by the master to duplicate that replica chunk into the other 2 nodes that are available. And the garbage collect button here is to trigger the garbage collection of orphan chunks in the replicas. And for the File Explorer, if I click on one of the chunks here, I can see this one's empty. Let's find a one that's populated. This one. And you can see the decoded append message belonging to that chunk. So the chunk stores this information in bytes. But in this file viewer, you can see it in the decoded JSON message. And that was after clicking the chunk file here. And if I click on the actual file itself, it will display interesting. It wasn't behaving like this before. But anyways,
It's okay.
Anyways, it will request information from all chunks and produce the final.
Okay. So Jay, let me quickly summarize, because we kind of running out of time for each of the project. We have a limited time. So that's good that you implement something which is called GFS Dashboard that allow individual user about their activity being you have the operational log, you have the Explorer, you have the client terminal, and then with a visualization to represent the message that's being sending between different replica and client and master. So I think that is a good tool, as you point out, that distributed debugging is actually very difficult, and the scalability is a major issue. So I saw what you have here is one client, and as you can imagine that a lot of this kind of distributed application, we have sometimes we have a large number of a client. It's not just me, but say other people are sharing the same file and things like that.
Right.
And what's your view? Who do you think will be benefit from the GFS dashboard? Is this going to be individual user, or is this going to be some sysadmin, say Google's GFS manager, that they actually try to look at all the activity? What do you see that who will benefit this most?
It will be the latter, because for the user, the end user wouldn't need this much information. All they would need is just the file explorer and the way to use this file system just like any other local file system. All this other information is unnecessary, and I think the purpose of GFS is just to try to mimic a local file system as close as possible.
Okay.
And
So
yes.
it's really for the sysadmin to
Mhm.
actually understand if there is any issues that's
Right.
related to their GFS, and they want to do some kind of debugging, and they can take a look at that, right?
Right.
Yeah. So one little comment is not really something that's actually I expect you to implement. I'm actually looking at your dashboard. I think that if there is any, if we look at the sysadmin look at this, it will be good if your display on the what you call the network section,
Mhm.
it will actually point out the label inconsistency and undefined. It will be good if you can.
Oh,
I mean,
yeah.
how do you actually display a inconsistent situation?
The inconsistencies are detected from the client side. So each chunk just sends their full append logs, and the client checks that the append has been checkpointed. And I check that through some labels, such as if you look here,
But the
this I.
but the sysadmin should have access to the log as well, right? So I can actually probably run the program over operational log and try to see if there is any potential, not necessarily definitely inconsistent, but potential inconsistent in the system, amount of inconsistent, or even harder is the undefined in the system. I mean, I give you an example. For example, if there is some concurrent write situation, then there could be some of the issue related to inconsistent and undefined, or there's a failure for the message. By the way, how will you represent failure? Say somebody deliver a message, it should have been sent, but it didn't send. Will you be able to detect that based on the data, based on the operation logs, and then display over there?
Yeah, so if the network, if one of the nodes is unresponsive, then there wouldn't be any lines originating from, say replica 0 is down, and if the client requests, or if the master requests something from replica 0, no line would originate from replica 0 back to the master.
Okay.
So you can see at that point where the network has halted, and it was because replica 0 has not responded in time.
Right. So let me say why I asked this question. This will be my last question, by the way, Jay, is that in typically today's distributed system management, or especially fault management, we typically have a two style. One style is proactive, means that all the event, like this kind of fault event, will go to the system and then trigger alert to the sysadmin about, oh, there are certain issue, and then the sysadmin has to prioritize that which failure will be more important to handle. But on the other hand, that there is also the other approach is essentially we just keep all the event but we didn't do anything until we actually have some service become unavailable. And when some service become unavailable, then this failure event provide an explanation, provide a reasoning about why this failure event that's actually happening. I mean, for example, if you have a lot of failure at the lower level, this might trigger some inconsistency in the data at the higher level. And so so in fact, it's not just about the display, but the log, and also the especially the log. How does this log be chained together? The event be able to provide some explanation about what's going on. Okay. That's good. I like the idea of GFS dashboard. And I think right now, I appreciate that you work on a very nice demo. I think there is some potential that you can continue and to talk about distributed system debugging. Distributed system debugging has been for a long time, but the thing is that we don't have a lot of good tool to do that. So maybe there's something which your idea might be extended to that. Okay. All right. So Jay, I just want to tell you that you haven't done your homework 2, homework 3 demo, right?
No.
Grading. Okay, I have to delay that. I will send you a message because the TA is not here right now. So I will send you a message. Then we'll arrange sometime later this week for you to do that. Okay. And
Okay,
but
sounds good.
yeah. Okay. All right. So I'm going to move to the second group. So can you unshare the screen to let the second group, Jing Xiao, Shushan, Yuan, and so everybody welcome to stay here. It's just right now it's their time. Yeah, go ahead.
So we can start right now?
Please.
Okay, so let me share my screen right now.
Hello.
Yes, go ahead.
Yeah. We are going to present our project, Tag the Object. It is the functionality that could help you automatically organize your system. We are going to introduce our project from 5 aspects. The first one is the initial idea, where the idea comes from. The second part is about what the project is. And then we will talk about the implementation and do a demo. Then we will introduce some future work that could extend our project. So let's first come to the first part, the initial idea. Why we are tagging the objects? Actually, objects can be anything in your system, your file, your folder, your application, and everything. So why we want to tag the files? The first reason is that from our observation and from our experience, we find that the current folder mapping cannot satisfy the requirements of many-to-many relations. So we need to find a new way to classify the object based on the current requirements. And the second thing is that there are, as I just mentioned, there are hundreds and thousands of files in my system. Most cases, I cannot remember the exactly position of each file. So I need to make use of the search functionality. But for current implementation, if I need to search a keyword, the system needs to loop all the files in order to find the file that match the keyword. So with tags, we can filter out most unrelevant files. So in this way, we can achieve a fast search with tags. And thirdly, we can use tags to predict users' intention and build a smart operating system. So for example, if the user tends to open files with tags ecs251 on Tuesday and Wednesday, then we can predict that the user has lessons of ecs251 on Tuesday and Thursday. So they may want to open the file with those tags on next Thursday and the next Tuesday. If the user sadly do not open these files. So maybe this means that their course is over and they will come to a new quarter. And but how to do the text? So if I need to manually maintain the many-to-many relationship with hundreds and thousands of files and many texts, that would be a huge work. So I hope that the system could help me automatically assign the text. To be more specific, I could create some tags and show some assignments to the system, and the operating system will help me automatically take care of the rest assignments. Now, let's move to next part, the exact project. You need to unmute.
Okay. Thank you, Zhishen, to talk about a promising story. So now we need to focus on how to convert the idea into a real project. So due to the time limitation, we're now able to just reverse engineer the whole file system in order to implement our idea. So we decide to use JSON RPC to simulate a file system. The structure is very similar to our home assignment. And instead of a file system, so we decide to let the user to create a new file onto the server side. And for the server side, there's always a background program running, and it is running for machine learning classification. And when user create a new file, and the background program could automatically classify the file and attach a tag with them. So after we present the idea to Dr. Wu, and he suggests us to involve a collaborator feature. So in order to feed more data into the machine learning algorithm. And lastly, our system can search by its tag. So it is more convenient for user to looking for the specific tag, the files they're looking for. So now I'll pass to Shuxian to talk about our implementation.
Okay, so as Jinxiao mentioned, we will utilize JSON RPC to demonstrate some of our typical use cases, and we will use server.cpp acting as a file system server, which can be either distributed file system or just any simple private file system. And the client one.cpp is used to behave as a normal user interacting with the server. As for tagging, we intend to use the recurrent neural networks to process variable lengths of data such as file content to create an embedding as a feature. Combined with the other categorical and numerical values, they will be fed into a deep neural network to do a multi-class classification. The tagging procedure on server side is invisible to user, which makes it more convenient and transparent. We will try to use some output to demonstrate our idea. Now, Yuan can show the demo.
Yeah. So let's first look at our client-side code. So firstly, I search file by tag. Here clearly I search the files, any files that is tagged UC Davis, and I create a file and tag, and I didn't tag it. And I just set the collaborators to user one, which is the same to the original file, homework one. And then I search file by tag UC Davis, and then I update the file homework two with the new tag called UC Davis CS. So then I search the file by tag UC Davis CS. So let's now take a look at how this program is running. First, I'll run the server. So right now the server is running, and then I'm going to run my client. We can see here, first, originally a file named homework one is created on the server side, and it's already on the server side, and it has a tag named UC Davis. Then when I create a new file named homework two, the server recognizes it because it's also created, the collaborators is also the user one, so it will auto tag it to the UC Davis. But at the beginning, when we created the text is empty, right? And when we then after creating it, after running our algorithm to auto tagging it, we actually got the homework 2 and tagged it UC Davis, and then we try to search the update the file homework 2 and to tag it as UC Davis CS. So after doing that, and we search file by tag UC Davis CS, we could see that homework 2 appeared, because it has two tags right now. The first one is UC Davis, and the second one is UC Davis CS. So it's more like a sequence of tags which we assign it. And our update function can provide our user, our client, to tag any file he wants. And if he doesn't do that, we can auto assign a tag to the file he just created. And that's our a little simple demo over here. And now Zhixuan is going to talk about our future work. You can start, Zhixuan.
Yeah, next slide, please. Yeah, I think there are two dimensions we can extend our projects. The first one is on the tag management. So for currently, the tags are created by user manually. The chances are good that the user may create duplicate tags like UC Davis and UCD. So if the system could automatically detect these duplicate ones and merge them, that would be nice to the end user. And the second on the tag management is that maybe we can find a better way to order these tags, maybe from the most frequent used ones to the least frequent used ones. Also, we can order the tags from the tag with the most files and to the tags with the least file. So in this way, the user can browse the tags in more user-friendly ways. So they may take most advantage from it. The next part on the tag management is about the suggestion part. So if we can suggest some users based on based on their preference, that would be nice, and users do not need to manually maintain these tags anymore. And the second way that we could extend our project is about the multi-file relationships. So we need to find a way to let the user provide their feedbacks to us on our recommending or assignment systems. So in this way, we can predict the user's intention more preciously. So that's all for our presentation. Thank you. Any question?
Yes. Okay. So I really like this project, and I feel your project really have potential, which means that I'm going to ask you some question which either you already thought about, or it's actually going to be very difficult. But don't worry. Just try your best to answer this question. Okay. So first, I feel that the automated tagging is an unavoidable trend. I mean, if we let user to manually doing their own tagging, it's just not going to be scalable, because we just have so many files. Because we think about this is essentially how many files you touches every day. Your email is a file. Your a lot of things. So essentially, we don't have time as a human being to do any kind of tagging. So we're expecting some automated process to automatically tagging a lot of stuff for me. And to be honest, with today's network bandwidth and storage, we actually don't worry about tagging a lot. We can actually tag a lot of information. Maybe the portion of the information for tagging may be even much bigger than the file themselves. That's okay, because of our storage, the big data is going there. So here I'm going to ask you this question to think about. So I'm actually comparing what you're doing with what Google is doing for 25 years. So what Google has been doing is that they in order for them to build the search engine, they actually pull out a data or a video or whatever content, and they actually use the best machine learning techniques or NLP techniques to actually look at the content and decide what are the most important information for what we call search keyword or search concept. So Google has changed a lot from the early stages, just look for purely keyword. But the modern, what Google has been doing is actually beyond keyword. They look at certain concept, they look at sentiment, they look at some other information together as well. I mean, I don't know what Google is doing exactly, but I believe they're making progress when we're using, for example, they look at diversity as well. About when you look at the keyword, they will actually provide you diversified result. Okay, having said that, I want to ask you a very challenging question. What do you think is the key difference between what Google has been doing and maybe they're doing right now and what you're doing? What do you think is the key difference?
Maybe I can start, and
Okay.
the team members could add their opinions later. So I think the main difference is the focus is different. We are focused on the files on personal computer on all some systems, but Google is the target of Google is for searching, I guess. As I just mentioned, text is not only for searching, it's also for building a smart OS for end users, and also to satisfy the many-to-many option, many-to-many relation on files and text. So it is benefit to end users, but for Google, they just want the search to become more smarter and more preciously. So they may assign text with their machine learning with their machine learning algorithms or something, but we are assigning text based on the user's requirements.
Okay, so the thing is that there's one thing called user requirement that you mentioned. The other thing you mentioned about private file versus say a public file, right? But
yeah,
assuming you actually store your file on Google Docs or Google Cloud, assuming we actually do that, and do you think that Google will not try to look at your intention, look at your requirement? I say I don't think we should be manually let the computer tell the system what should be their requirement, right? The system is supposed to be smart enough to actually understand that what is the, so essentially Google can provide a service. If you use Google Dot and all this Google Cloud, then essentially they can actually do that, right? They can actually also look at your file and provide a next generation of Google Docs. I mean, this will be their feature, right? They compete with other cloud service between Microsoft, AWS, and they can actually do exactly what you, by the way, it's a great idea that Google will do exactly what you're doing on all the file you store on Google Cloud and Google Doc, such that they have a much better, it's like your search engine is fully integrated with your personal space, with the public space. I think that's another thing that's actually very interesting. Okay, so let me tell you that there is no good answer to my question. That's why I say it's very challenging. So I don't expect you to come up, but I think Zhishuan, your answer is already much better than what I expect from you. Okay, so you're doing good. Don't worry about that. So let me actually tell you my opinion that why I got excited about what you're doing. So a lot of the Google stuff, number one, they're actually looking at the file itself. They mainly look at the file itself. When they do search engine, they do extract the keyword, whatever, they focus on file only. If this is a video or this is a file, I do search engine, I do crawler. I mean, search engine usually start with crawler, right? So they look at the file itself. But in your tagging, I think it's more exciting. It's not just about the file, but also about the people, about the environment when the file are being accessed. And that is a tagging. If Google want to tag, they have to actually break into our privacy. So essentially right now, if you think about that, we have a file called PowerPoint that 5 or 6 of us are accessing right now. This is a file. We can actually extract a lot of keyword using RNN or whatever to actually look at the sentiment, look at what the file is actually talk about. And the thing is that we have a YouTube video later, which record our discussion right now. Those are the content we can extract. But the thing is that we have other information that's actually not necessarily directly related to the file. It might be related to today is the final project presentation day. That information is not included in the file directly. And where is our location and what's the relationship? There's a lot of information that's actually privately owned by each one of us. Our phone might be able to record that. But the thing is that I think that information is interesting. So when I look at this tag, I'm actually thinking, oh, this is going to be privacy protected, meaning that we actually tag, but those things are not going to go out to let any public company to grab that. We might share that later, but we actually do this ourselves. And then among 5 of us or 6 of us, because we're actually in the same classroom, we might, if we willing to do that, we can actually exchange what we tag. And then we can actually put a better picture. So our search engine is not going to be searched just for when, say, 20 years from today, the tag might not be just search for a particular keyword or particular concept, but we can actually look at a lot of other stuff that's actually going to our memory about how do I record this. Let me give you a very challenging task for tagging. So we talk about tagging in your example. I think that's fine. But let me actually say that during our discussion, at one point, we actually talk about, hey, do you like coffee? Or do you like to have some Chinese green tea? And we actually sidetrack a little bit into some of the subject that's actually not the mainstream. So if we look at the content, those information are irrelevant. Why you talk about coffee? Why you talk about peace coffee versus, but that information sometimes is our memory. Those kind of peripheral information sometimes will actually help us to reconstruct this conversation in a different way. And that help us to maybe pinpoint, say, I remember I talked about coffee right before I talk about that particular point. Then essentially, if you didn't catch that coffee information, then I cannot use that to catch that. So I'm just maybe in the middle, we're talking about some movies. So I'm actually thinking, I'm just going crazy a little bit, that if our hard disk space is actually huge, infinite, our computational power is actually close to infinite, then why can't we actually tag as much as self for ourselves? And so we can actually be able to construct a better, lively picture about our life. Yeah, that's some of the comment. I feel that what you're doing is really great. I feel that if you keep developing this idea, you're actually going to change the way Google is doing business, or many of the other are doing business. So that's why I encourage you to think about this. Tagging is a very important topic. It's an old topic, by the way. And the big company already doing tagging. You can think about any company you have, they're doing tagging, but they're doing a tagging in a narrow way, in my opinion. So think about this. Maybe you can come up with something which is a disruptive way of looking at tagging. Okay. All right.
So,
thank you for your hard work. Yeah, go ahead.
So, Professor, I have one question. So, what you are suggesting is actually we can tag the person or tag the user, right?
Right. We can tag the person, tag the user, tag the voice. Because when we discuss, we have our voice, right? The voice can be recorded. I mean, by the way, when I think about tagging, I'm not thinking about tagging as a single word. A tagging could be a segment of conversation that's actually being recorded. So we're actually linking a particular segment of voice with some content, with a slide. So I mean, obviously, Google, they can probably do that if they violate our privacy. But the thing is under our control how do we actually record? I mean, voice is something which is, I think is very efficient to record. And we have a lot of signal processing technology to try to understand the speech. And for example, and it can catch a lot of interesting information. And of course, it could do facial recognition as well. We do a facial recognition with ourselves and see how let me give you an example. I'm actually looks happy, but at some point I suddenly looks a little bit angry in this discussion. Just assume that was the case. So later I will say, hey, I remember there was one time I was disappointed. I was really angry at this group of students presentation. Can you actually pull it out when I actually have that? And then that would be really interesting for us to know. I mean, our life is moved so fast, but those moments are game changer, and sometimes we want to catch up. And I don't think today any of the search engine allow us to be able to go down to that level of privacy and go down to that level of detail feature for us to extract certain content. Yeah,
I feel like if we need to accomplish that, we need to record every event happened at any time. So at a future time of point, we can recall what happened at what time with what kind of people.
Right.
Yeah.
Right.
So we can can build a knowledge graph that can connect everything in our system so that we can search the relationship.
Right. I think that is a good point. I feel that Shushan, what you're saying is hinting at number one. Do we want to record everything, right? I mean, number one, do we want to record anything, assuming we can protect the privacy, and would that be too inefficient? So maybe the initial idea is, okay, if we record everything, what will happen? Then we actually try to design the system a little bit different. Say, what kind of thing we think is most relevant for us to record. And so this will be a learning, but it will be a long-term learning because we'll see how people decide to use this information, to use the search engine, to use the tag. And then that feedback might actually trigger us to decide what kind of information we'd like to record. And also depending on case by case. For example, some of the discussion meeting, we want to record more. And some of the information, if it's already, how do I say that, duplicate. Like I always go to the routine, go to this coffee shop to get a coffee, and maybe I can actually reduce that. So that itself, it will be a really interesting topic by itself. Yeah, but I think it's a time for us to think about a different way of doing things, like what the industry has been doing. Yeah. Okay. All right. Great job, and appreciate that. Let me see. Why I have this one here? Okay. Okay. Yeah. Okay. I think you guys are done. I'm going to, let me see. Hey, Francesco, thank you very much for your hard work. And that's great. I think I catch all of your name. Francesco, Francesca or Francesco?
Francesco.
Francesca, your appointment is 10 a.m., right?
Correct.
Yeah, okay. So I'm going to stop the recording right now and then resume at 10 o'clock. Will that be okay?
Yeah, totally fine.